Welcome to The Explainer. Today, we're diving into some really fascinating new tech. Think of it like an emotional barometer, but instead of weather, it uses robots to measure the hidden feelings that actually drive our decisions as consumers. Okay, let's get into it.
So, let's start with a big question. What if a brand could understand how you truly felt about a product or an ad, maybe even better than you understand it yourself? You know, there's often this gap between what we say we want and what our gut reactions are really telling us. And that's exactly what we're going to explore, the technology that's trying to bridge that exact gap. It's all about reading the unspoken signals that our minds and our bodies are constantly giving away.
You see, for decades, marketing has leaned on things like surveys and focus groups. And look, they can be useful, but they have this one fundamental flaw. They only capture what we're consciously thinking. They get what we think we feel, which, let's be honest, can be influenced by anything from peer pressure to just having a bad morning. The real, raw, unfiltered emotion, that often gets completely lost. And this is where you can really see the massive shift. The old methods, they rely entirely on what people say. But neuromarketing, it just kind of bypasses that conscious filter altogether. It goes right to the source, measuring those subconscious signals to figure out what people genuinely feel. Honestly, it's a total game changer.
So the big question is, how do you actually capture these feelings out in the wild? You know, in a place like a busy store. Well, this is where robotics enters the picture, creating what we're calling a robotic barometer.
First things first, let's get our key terms straight. Neuromarketing. It sounds complex, but it's really just the science of looking at those hidden, subconscious thoughts and feelings that push our choices. It's the why behind the buy that, a lot of the time, we can't even explain ourselves.
And here's the cool psychological trick that makes robots so good at this. It's a thing called anthropomorphism. It's that natural, totally human instinct to treat non-human things, especially something like a friendly-looking robot, as if they have feelings and intentions. Because we do that, we end up acting more naturally around them, which gives them a perfect little window into our genuine reaction. This quote really nails the core idea. The robot isn't just some clunky machine. It becomes this incredibly sensitive instrument. It's not just checking if you're smiling or frowning, it's sensing these tiny shifts in your internal atmospheric pressure. You know, your excitement, your stress, your confusion, all in real time.
Okay, I know, this might be sounding a little bit like science fiction, so let's make it feel real. Let's imagine we're walking into a store of the future, one that uses this exact technology right now.
All right, so you walk in and this robotic assistant rolls up and greets you. From that very first hello, it's already observing. As you two interact, its neuromarketing models are crunching the data on your subconscious signals. So, if it senses you're getting, say, overwhelmed by a bunch of technical specs, it might instantly pivot its strategy and tell you a story about the product instead. It's communication that literally adapts to you, moment by moment. That's a pretty compelling idea, right? But what is the robot actually seeing? What are these subconscious signals it's supposedly picking up on?
Well, it's looking for a whole bunch of tiny, involuntary tells. We're talking about things like fleeting facial microexpressions that last for just a fraction of a second, the subtle stress indicators in your voice, your body language, how long you hold eye contact, even your response latency, which is just that tiny, tiny pause you take before answering a question, a pause that can signal you're thinking hard or maybe feeling a little unsure.
Okay, so here's the really crucial part. How do these raw signals turn into something meaningful? Well, for example, that long pause before you answer, that could signal cognitive overload. You're thinking too hard. Making more eye contact, that suggests you're highly engaged. And those little positive micro-expressions, they can be read as signs of growing emotional trust. This isn't just random data. It's basically a map to your internal state.
So, this technology is, well, it's clearly incredibly powerful. But all that power brings up some really important and frankly tricky questions about how it's used and what it means for us. Which brings us to the core conflict of this whole thing. Is a robot that can read your feelings the ultimate helpful shopping assistant we've all been waiting for? Or is it a creepy invasion of our private emotional space? The answer, as you can probably guess, isn't that simple.
Now, from a business point of view, the goal is crystal clear: personalization at scale. The dream is to give every single customer a perfectly tailored experience, one that clicks with their unspoken needs and feelings. The whole idea is to finally move past one-size-fits-all marketing into something that feels like it was made just for you.
But, and this is a big but,
For any of this to work without a massive public backlash, a super strong ethical framework is absolutely essential. We're talking about total transparency about what's being measured, getting real informed consent from people, managing all that data responsibly, and most importantly, building genuine consumer trust. Without these guardrails in place, the whole thing could just fall apart. And so this is where we'll leave it. There's really no doubt that the future of how we interact with brands is going to be more and more personalized. But the big, lingering question this technology forces us to ask is this. As we move into that future, who gets to set the rules? Who defines that line between a helpful experience and an invasive one? That's something we're all going to have to figure out together.
You know that feeling, right? You see one robot and you're like, "Aw, that's adorable." But then you see another one and something's just off. It feels kind of creepy, like it's trying way too hard to be human. Well, it turns out the secret to making a robot we actually like isn't about better gears or smarter code. To build the perfect robot, we gotta look somewhere else entirely. Not at their circuits, but inside our own brains. Let's dive in. So yeah, that's the big question, isn't it? How can one pile of metal and wires feel like a buddy while another one just gives you the creeps? That line between lovable and unnerving is razor thin. And to figure out why, we have to start by looking at the problem itself. And believe it or not, this creepy robot problem isn't just you. It's a real well-documented thing, and it has a very specific name. And it just so happens to be one of the single biggest hurdles in robotics today. It's called the uncanny valley. Picture this. It's that massive dip in our comfort level when a robot looks so close to being human, but something's just wrong. Maybe the eyes don't quite track right, or the smile's a little too stiff. Whatever it is, our brain immediately flags it as imposter, and that's what triggers that feeling of deep unease, or even disgust. And look, this is way more than just about making better-looking robots for movies. This feeling, it's a huge roadblock. I mean, think about it. If we want robots helping out in hospitals, caring for our elderly relatives, or assisting us in stores, we can't have people being actively freaked out by them. Getting past the uncanny valley isn't just a fun design puzzle. It's absolutely critical for the future of how we live with technology. So how in the world do designers even begin to navigate this? Well, it's an incredible balancing act. It's like walking a tightrope over a giant chasm of creepy. They are literally walking this tightrope of design. On one side, you can make the robot too machine-like, right? Think of a factory arm. It's useful, sure, but you're not going to form an emotional bond with it. But if you swing way too far to the other side and try to make it perfectly human, but you miss the mark, bam, you fall straight into the uncanny valley. The whole game is finding that sweet spot right in the middle. And this idea of a social bridge, that's the perfect way to think about it. Giving a robot some human-like qualities, which is called anthropomorphism, is supposed to help us connect. It's building a bridge between us and the machine. But if you build that bridge wrong, if it looks right but feels off, that bridge doesn't just fail, it collapses. And it ends up creating fear instead of trust. So, if the problem is that deep in our psychology, where do you even look for a solution? Well, get this. The breakthrough is coming from a field you would probably never guess. It's got nothing to do with engineering and everything to do with understanding us. That's right. The key to building a robot we can trust isn't found in a computer lab or a workshop. It's found by studying the automatic subconscious reactions that happen inside our own brains every single time we lay eyes on one of these machines. And the field leading this charge is called neuromarketing. Now, I know what you might be thinking. Isn't that for designing soda cans and catchy ads? And yeah, that's where it started. But its tools are perfectly suited for this because they let scientists measure our gut reactions, the stuff we feel before we even have a chance to think about it. So how do they actually do this mind reading with some seriously cool tech? They use EEG caps to measure brainwaves and see what parts of a robot's design get our attention. They use eye tracking to see exactly where we look and what we ignore. Biometric sensors can pick up on a tiny spike in anxiety just by measuring the sweat on our skin. And facial coding software can analyze microexpressions to see if we're truly happy or just faking a smile. It's the closest thing we have to reading the subconscious. Okay, so we've got the mind-reading techs. Super cool. But how does that actually translate into building a robot we actually like? Let's look at how this all works in practice. This is where the science turns into design. For example, when trying to make an appealing face, EEG data shows that stylized, cute features, think big eyes, round shapes, literally light up the reward centers in our brains, way more than hyper-realistic features do.
For making interactions feel natural, eye tracking shows that dynamic eyes that move and react build way more trust than static glossy ones. And to reduce anxiety, biometric sensors have shown that for certain people, a less human design is actually more comforting.
This finding is just fascinating. Take a robot like Pepper, which you might have seen in a mall. Researchers found that having its eyes change color or shape to show it's listening was way more effective for building trust than trying to perfectly copy human eye movement. Why? Because it signals that it's socially aware without trying to trick our brains and falling into the uncanny valley.
And this is absolutely crucial. One size does not fit all. These neuromarketing studies have shown that different groups of people react very differently. For example, many older adults show way higher subconscious anxiety when they see a highly realistic robot. For them, a design that is clearly a friendly machine is often much more comforting and easier to trust.
So where's all this headed? What's the big picture? Well, it's about so much more than just a few design tweaks. We're talking about fundamentally reshaping how we're all going to coexist with these machines in the future.
So, the whole process, the playbook for building that perfect social bridge, looks like this. Step 1, you measure our brain's raw, unfiltered responses. Step 2, you use that data to fine-tune social cues like eye contact and tone of voice. Step 3, that helps designers find that perfect sweet spot that avoids the uncanny valley. And the final goal? To foster real trust and acceptance.
And really, in the end, this isn't just about selling more gadgets. Not at all. By digging deep into our own subconscious reactions, we're actually laying the groundwork for a future where humans and intelligent machines can work together, naturally, positively, and effectively.
And that leaves us with one final big idea to think about. In this whole quest to build the perfect robot, to create a machine that understands us so well, what we're really doing is holding up a giant mirror to ourselves. We're decoding what it actually means to connect, what it means to trust, and maybe what it even means to be human.
You know, we're right on the edge of one of the most exciting frontiers in technology. And that's building machines that don't just compute, but actually comprehend. And that's where we see this incredible connection between neuroscience and the future of robotics really come alive.
I mean, just think about it for a second. What if you had a robot that could learn from experience, that could adapt to new things on the fly? Kind of like a toddler figuring out how to walk. Well, this isn't science fiction anymore. It's the real central goal that's driving a massive revolution in robotics today.
And this whole scientific revolution, it has a name: neuromorphic robotics. It's all about looking at the ultimate blueprint for intelligence, the biological brain, and using its principles to build way smarter, more capable machines. We're pretty much reverse engineering nature's greatest design.
Okay, so how does this actually work? Well, first, let's dive into how these brain-inspired designs are totally changing the way robots sense and learn from the world around them. This is a huge leap away from that old, rigid way of programming.
For decades, right, robots were stuck on this rigid, rule-based code. If a situation wasn't perfectly pre-programmed, the machine was totally lost. But this new, neural-inspired approach, it's the complete opposite. It's designed from the ground up to be adaptive and robust, so it can handle the messy, unpredictable nature of the real world, just like our own brains do. So by basically copying our brain's playbook, these new robots can take in a flood of sensory data, vision, sound, touch, you name it, and actually make sense of it all in real time. They can filter out all the noise and focus on what's important, which, let me tell you, is an absolute game changer for navigating our chaotic world.
And we're not talking about just feeding a robot a giant pile of data all at once. Nope. It's an active, continuous loop. The robot interacts with the world, it gets feedback on what it does, often through these little reward signals that are kind of like the dopamine hits in our own brains, and then it adapts. And that final step is the secret sauce. It adjusts its internal models. This is inspired by something called synaptic plasticity, which is how the connections in our own brains get stronger or weaker. It's literally the foundation of how we all learn.
And believe me, this isn't just some abstract lab experiment. This kind of adaptive learning is absolutely essential in some really high-stakes fields. I mean, think about a surgical robot in a hospital, a self-driving car on a busy street, or a rescue robot digging through rubble after a disaster. In those situations, being able to learn and adapt on the fly isn't just a cool feature, it's a flat-out necessity.
So being able to see and understand the world is one thing, but actually moving through it, well, that's a whole other challenge. And that brings us to the quest for natural fluid motion.
I just love this quote because it really nails the ambition here. You know those clunky, jerky movements we all picture when we think of old robots? That's out. The new goal is to replicate the grace and efficiency you see in nature, motion that's both powerful and precise, stable but also agile.
So how on earth do they pull this off? Well, by copying the brain's own command structure. See, our brains use this amazing hierarchical system. We've got low-level reflexes for things like staying balanced, mid-level learned skills like walking or grabbing something, and then high-level conscious planning. By building that same kind of architecture into robots, they can manage these super complex movements without having to think about every single tiny adjustment.
And the applications for this are just incredibly powerful. This is the kind of approach that's going to lead to truly dexterous humanoid robots. It's the key to building advanced prosthetics that actually feel and act like a natural part of the body. And, on a really practical level, it just makes robots way more balanced and energy efficient.
Okay, so this brings us to what might be the most crucial piece of the whole puzzle. As robots start moving out of factories and into our homes, our offices, our lives, they don't just need to be smart, they have to be social.
For a robot to work safely and effectively with us, it needs a basic level of social intelligence. And guess what? We turn to neuroscience again. By studying how we humans communicate, researchers are teaching robots to understand our social cues, everything from facial expressions to tiny gestures, and to respond in a way that feels natural, intuitive, and not,
But of course, as soon as you give a robot social skills, that immediately opens up a huge, profound ethical question. As we build machines that can literally interpret and react to our emotions, we have to seriously figure out how to make sure their decision-making lines up with our deeply held human values.
And what's fascinating is that neuroscience might offer the tools to help us here too. By understanding the very basis of our own thinking and moral reasoning, we can start to build actual frameworks for ethical AI. This is what's going to help us design responsible systems that we can actually trust to make the right call in tricky social situations.
So let's pull all of these threads together for a second and look at what this incredible convergence of neuroscience and robotics really means for our shared future.
If there's just one thing you take away from all this, it's got to be this. Neuroscience isn't just helping robotics. It is fundamentally driving its evolution into a whole new era.
We are really witnessing a monumental shift here. The era of the rigid, pre-programmed machine is coming to an end. And in its place, we're starting to build something completely different, truly adaptive, intelligent partners that are designed not just to do tasks, but to actually collaborate with us.
And that just leaves us with one final, provocative thought. This future, it's not some distant dream. It is being built in labs as we speak. These brain-inspired machines are on their way. So the only real question left is, are we ready?